for here, they give us the sequence an equals 4 plus n minus 3n squared over 4n squared plus a 1. So for here, we have to find the limit of this sequence. So we're going to utilize the theorem. I believe this is on. Okay, so we're going to use theorem number 1. If you want to reference it, on page 545. Okay, and this is the one where we basically can use the function form f of x, and this equals the limit of the sequence an. Okay, so here there's kind of just a connection between the f of x and the an, right? So we can represent this basically as a function where we just replace the n's with x's. It's just as simple as that kind of thing. So 4x squared plus 1. So if we prove the left side, then that's going to prove the right side as well. Okay? So if we set this up into limit form, we're going to plug in our f of x now, is this, 3x squared, 4x squared plus 1. So if we try to take the limit now, we're going to get some infinity over infinity, which is not good. So as we know, we're going to employ L'Hopital's rule, and we're going to take the derivative of the top and then put it over the first derivative of the bottom. So the first derivative of the top, well, why did I put a line there? Hold on, I was thinking about fractions. Okay, so limit as x goes to infinity of, now the first derivative of the top is 4 turns into 0, and then there's a 1 in front of the x, and then minus a 6x over 8x. So let's try it again, and we get some infinity over infinity. So we have to do it again, L'Hopital's, and then we get limit as x goes to infinity of negative 6 over 8, and this is simply negative 6 over 8, which reduces to negative 3 over 4. Okay, so then by the theorem, so we prove the left side, and this also has to equal the limit of the sequence. Okay, so that is it for that problem.